Question number 14. So we have three combinations of resistors here. So the resistors are all identical. Another meaning for the resistors being identical is trying to say that they all have the same resistances. So looking at the diagram for, looking at P, that's the diagram for P, Q, and then R. Now this is a very tricky solution. The question is not difficult, but then the solution can be a bit tricky. So let's look at how to go about solving this question. Now, since the question is telling us that the resistors are similar or they're identical, it means that we are picking all their resistances to be R. So let's take for P. For P, this is a diagram for P. We have two resistors that are in series, two that are in parallel. So for the series connection of resistors, we can write that the combined resistance is 2R. Then for the parallel combination of resistors, we can say that the effective resistance for the parallel is R over 2 or half R. So the total resistance for the connection P is given as 2R plus half R, which should give us 2.5 R. Now to make your understanding very good and to make your solution very quick, I would say you could use a value for the resistance of the resistors. So let's say that R is given as 2 ohms. So if we pick and we fix the 2 ohms for the solution we've just gotten for the total resistance, we are getting our total resistance to be 5 ohms. That is for P. Okay. All right. Now let's go to Q. Q, we have one resistor that is in series with 3 resistors that are in parallel with each other. So the series connection, the effective resistance is just R. For the parallel connection, the effective resistance should end up giving us R cubed over 3R, which is the same as 1/3 R squared. So if we add the effective resistance for the parallel connection, this is for Q, the effective resistance for the parallel connection to that of the series connection, we should get our total resistance to be R plus 1/3 R squared. If we fix our same 2 ohms we used for the connection in P, if we fix that in the connection for Q, we should end up getting our total resistance to be 3.33. So we are just realizing that the value for the connection, the total resistance for the connection in P is bigger than that of Q. Let's look at the last one. The last one is for R. So we have one resistor and then we have other 2 resistors that are in a parallel connection with one resistor. Okay, so we have for the series connection, let's look at the first one. Effective resistance is R. Now for the second series connection, we can find the effective resistance there to be 2R. Now that becomes a single resistor that is now in parallel with the resistor on top of it. So we have 3 connections now, R and then R on top and then 2R beneath, forming a parallel connection for the second set. So for the parallel connection, we can get an effective resistance of 2 over 3R. So when we add that value for the parallel connection to the series connection, we are getting our effective resistance to be 5 over 3R. If we fix the same 2 ohms we are using for the value of R in this particular total resistance for R, we are getting our total resistance to be 3.67. What it means is that for the connection in P, the total resistance was 5 ohms. For the connection in Q, the total resistance was 3.33 ohms. For the total resistance in R, the total resistance was, for the connection in R, the total resistance was 3.67. Mind you, these are just dummy values we use. Okay, we use 2. Somebody could have used 5 or any different value for that matter. Now from this, we can conclude that if we are doing it just like our question is asking us to do, then it means that Q and then R and then P. Okay, Q and then R and then P. Now this is because the question is asking us to arrange the resistors in increasing value of resistances. So Q is the smallest, followed by R and then P. So switching back to our question, we see that from the possible answers we have, the correct one, Q and then R and then P. So our correct answer in this case is D. All right.